So, in continuation of acids and base, we are now going to talk about the pH of solutions. Now, the pH of solutions basically is the strength of acids and the strength of bases. The strength of acids are based on pH or pOH. pH is the power of hydrogen ion or hydronium ion concentration, and pOH is the power of the hydroxide ion concentration. So pH is if you're looking for how acidic or basic it is, and if you know the concentration of your base, you can figure out the pOH. Okay, so prior to watching this video, you should go ahead and you should have already completed looking at the simulation activity and played around with the concentration of hydroxide versus concentration of the hydronium ions. And if not, you should go ahead and do so now. But what you should have determined is that the concentration of your hydroxide and hydronium ions are very interrelated. So when you increase the concentration of your hydronium ion, you should notice that the concentration of your hydroxide should decrease. And vice versa, if you decrease your concentration of hydronium ions, your OH concentrations increased. The part you should notice was that if your concentration was 10 to the negative 7 and 10 to the negative 7 for both, you ended up being neutral, because this is pH 7 where it's neutral, and you have the same amount of hydronium ions as you do with the hydroxide ions. And this is the key factor of why we talk about neutralization. The pH is pH and pOH are equal. So let's go ahead and talk about the next slide. The pH of a solution is based on a 14 scale, pH 1 being the most acidic, pH 14 being the most basic, and the neutral is going to be pH 7. And pH 7 is when your concentration of your hydroxide ions are going to equal the concentration of your hydronium ions. And so the three equations that we need to talk about really relates to this pH scale. And the first one we'll talk about is how pH plus the pOH is always equal to 14. If I know one of the two, I can always determine my what the pH is if I knew pOH. And so if I knew pOH, I could have pH is equal to 14 subtracted by the pOH. Also, if I knew my pH and I wanted to know my pOH, I would just take 14 and subtract that by my pH. Now, the other equation that you need to know is pH is equal to the negative log of the concentration of hydronium ions. Your answer should always be positive. If it's negative, that's going to be an iffy, because you shouldn't have a negative answer. And the other equation you should know, pOH is equal to negative log of the concentration of your hydroxide ion. So these three are going to be really important to know. With that said, let's go ahead and do some examples. So if we calculate pH, we know the concentration of our acid. So remember, pH is equal to the negative log of our constant hydronium ion. Our acid is HCl. L, and that's equal to 0. Or concentration, sorry, I need to put that in bracket, is equal to 0.10 molar. Now, if we break this down, our hydronium ion concentration should equal the same amount of concentration as our HCl. So I can go ahead and put this into the equation. So pH is going to equal negative log of 0.10, and you should end up with a pH of 1.0. So our pH is 1.0. Now in this example, I'm asking you to go ahead and calculate both the pH and pOH. Now, since we have a 0.25 molar solution of nitric acid, so I know I have an acid, that means I can calculate my pH using the equation pH is equal to negative log of the hydronium ion. HNO3, if we break this down, ends up having ions of H plus and NO3 minus. So since it's a 1-to-1 ratio, my concentration of hydronium is going to still be the same as the concentration of nitric acid, which is 0.250 molar. So if I go ahead and plug this into the pH equation, pH is equal to the negative log of 0.25. My pH should be 0.600 is going to be my pH. If my pH is equal to 0.600, I can figure out pOH by using the other equation that I had introduced. pH plus pOH is equal to 14.00. So I can figure out pOH by taking 14.00 and subtracting 0.600 from it, and you should end up with 13.40 as your pOH. In this example, we're going to slightly change our acid. In example 1 and 2, we worked with monoprotic acid. Here we have a diprotic acid. And what I mean by a diprotic, if I break down H2SO4 into its ions, I would end up with 2 hydronium ions and a sulfate ion. Now, my original concentration of my sulfuric acid was 0.34 molars, but because if we do the mole-to-mole ratio and do the stoichiometry with this, you end up having your hydronium ion being 2 times greater than your sulfuric acid. So this is my concentration for my hydronium, and that's 0.68 molar. If I put this into my equation of pH is equal to negative log of my hydronium ion, you should end up with 0.17 as your pH. Again, I can figure out my pOH by the equation pH plus pOH is equal to 14. And so pOH is equal to 14, subtract pH from that, and you would end up with 13.83 as your pOH. Now try calculating it for example 4 and for example 5. And I want you to notice for example 5, I'm not giving you the concentration of your acid. Instead, I'm giving you the information that you have 13 grams of your hydrochloric acid dissolved in 2.5 liters. But you should be able to calculate pH and pOH from this. And with that said, we will go over examples 4 and 5 in class, and you can go ahead once you're finished with the 2 examples, move on to the next video for titrations.